Okay, today is a special dress-up day at Elberly High School. Christy Munson, would you like to tell them who I am?
Mr. Incredible.
Now, is that just my costume or am I really incredible? Christy is not responding. What's that? What? Well, these aren't underwear. Mr. Incredible doesn't wear underwear over his costume. That would be stupid. These are special spandex shorts he wears to pits. Oh my gosh. You guys are being mean. Okay. All right. First problem. We're going to get through 3. Example A says John can paint a house in 32 hours. Eric can paint a house in 24 hours. How long will it take them to paint a house together? Well, that's easy. Just average, right? Okay. Yep, mathematics does make many assumptions that we try to work through. You're absolutely correct, Julia. Well, how about this? Is it going to take them more than 32 hours to do it together? Is it going to take them more than 24? No, because if he can do it all by himself and he has help, then it's going to take less than what? 24. So we'll say that time we know is going to be less than 24. Furthermore, if they both could do it in exactly 24 hours, if they both could do it in exactly 24 hours and they were working together, how long would it take them? 12. So the least amount it could be would be 12. The greatest amount could be 24. So, it's important to understand a problem in the context which is presented so you know if your answer is at least within the realm of being possibly correct. So something we need to talk about here is this. Distance is equal to your rate times your time. So if you are driving in a vehicle and you want to know how far you've gone, you would take your speed and multiply it by the number of hours that you've been driving, right? You could also solve for R. R is equal to time. Whoop. R is equal to distance divided by the time. And you also know that time is equal to distance divided by the rate. So there I have all 3 formulas. Now, I want to refer to distance in this problem as referring to the amount of work that's being done, what's being accomplished. So I'm going to make this suggestion to you. If we take John's work, the amount that he does, and we add it to Eric's work, the amount that he does, we will get the total work accomplished. So how many houses are they trying to paint? 1. So John's work can be expressed like a distance problem. The amount he does is his rate times his time. Do we know how much time it's taking him to do it? No. What is his rate? He can do 1 house every, so 1 over 32. Plus, what's Eric's rate? 1 out of 24 hours times time is equal to 1. I can use T in both scenarios because they will finish at the same time as they are working together. So it'll take them the same amount of time to work together and complete the job. So this turns into T over 32 plus T over 24, which is equal to 1. How do I solve that equation? Make the denominators common. I multiply the top and bottom by 3, top and bottom by 4, so my common denominator will be 96. 3t over 96 plus 4t over 96 is equal to 7t over 96, which is said to equal 1. In order to solve for t, I multiply by the reciprocal. Thank you, Chrissy. 96 over 7 is equal to t, which is approximately, what, 13.71? questions on that? Yeah. What? Whoa. Yeah. So if you take this right here, 96, and this 7, you're going to get t is equal to 96 over 7. Yes, no? Okay, try one more time. That's my equation, right? Multiply by the reciprocal. Okay, all right, okay, now you got it. Good. Okay, that's the first problem. Are there any questions on that problem? Questions going once? Questions going twice? Three times and gone. You guys need to wait 55 more seconds. I'll let you 2 minutes early. 2 minutes early. Okay. I'm not going to get through this, but you guys can wait 45 seconds now. After robbing a bank in Dodge City, a robber gallops off at 14 miles an hour. 10 minutes later, the marshal leaves in hot pursuit at 16 miles an hour. How long does it take the marshal to catch up with the bank robber? This is a little bit more difficult of a question. We'll get to it after we wish our good friends a farewell. Okay, let's give this a shot. Robbing a bank in Dodge City, robber gallops off. So we're wondering how long it takes them to meet up at a certain time. So if they take off from this point A, and this is the robber, and then Marshall takes off. Whenever they catch up, their distances are going to be the same, right? So we're wondering when the distances are the same. So we really need the robber's distance and we need the marshal's distance. And then we can set them equal to each other. And we learned from our equation above that distance is equal to your rate times your time, right? So the robber's distance is equal to his rate. What's his rate? 14 miles an hour. So multiply it by, I guess instead of h for hours, I'll just use t for time. And then the marshal's distance is 16 times the amount of time. But there's a little bit of a catch to the problem here. They're not leaving at the exact same time, are they? The marshal gets a little bit, or the robber gets a little bit of a head start, right? So how far ahead is the robber? I mean, we got to add on his head start here. 10 minutes, but we're expressing it in terms of distance. So how far has he traveled in 10 minutes? How far would he have traveled in an hour? What's his rate? 14 miles. So 10 minutes is 1/6 of an hour, right? So he would travel 14 times 1/6 hours. Can you guys agree that when their distances are the same that they've traveled, that's when they're going to catch up? So I could set them equal to each other. So 16t is equal to 14t plus 14 times 1/6. 7/3. Solve by subtracting my 14t. I have 2t is equal to 7/3. Divide both sides by 2. T is equal to 7/6, or 1 1/6 hours, or 1 hour and 10 minutes. Hannah, you're looking at it kind of angrily. This part right here, Well, so we got 2t equals 7 over 3. So let's do it like this. To get rid of 2, I can multiply both sides by 1/2, right? Times 1 over 2. So t is equal to 7 over 6. 7/3 times 1/2 is 7 over 6, yes? Okay. So when you divide a fraction, you just really need to multiply the denominator by what you're dividing by. The key is to be able to set up, I mean, you know, you guys could get through the algebra. The whole key is can you set it up? And that's what we're trying to spark in your mind, is that setup process. Okay? So I know these aren't easy. Very normal to have questions. And that's why you're going to have time to work on Friday. That's why you're going to have time to work on Monday, so you can ask questions of me. But when you get your homework test, I really don't want to answer any of your questions on the homework test. I will answer questions about the homework. I'll answer questions about the notes. I'll answer questions about the video. I'll answer questions about the book. You can draw a problem identical to it, and I will go through it. But some of these problems you're going to have to do on your own. Okay, all right. This is the tough one. You're going to need a scratch sheet of paper for this one. We don't have near enough room. So go ahead, take out a scratch sheet of paper. This is going to take a while. This is the last one. Part of my horrible notes, I wrote them last year. I didn't make the necessary corrections to them. I apologize. So the actual language doesn't always make sense, but it's pretty close. What are you laughing at? Oh, my art skills? Or my lack thereof? I think that anytime you have water, you should probably have a shark, right? So how does a shark tail go? It is like that. There's my shark. Look out for the shark! What? Looks like a catfish. Whatever. Teeth look like whiskers. All right. I'm gonna put that's a bunch of blood in his mouth. Here. How about this? All right. He ate somebody. All right, there you go. This is Larissa. Larissa's gone. Tinkerbell. There you go, Riz. Sorry. Okay. All right. So we're on a boardwalk, the problem says, and it says that the boardwalk runs parallel to the seashore, and it also says that this guy's trying to walk to his umbrella. Exactly how far is he from his umbrella? 750 feet, it says. How far is the boardwalk from the shore? $210. Here's the question. How far should he walk on the boardwalk and on the sand so that he gets to his umbrella in exactly 4 minutes and 45 seconds? Now, this sounds stupid, right? I mean, honestly, wouldn't he just, enjoy the walk on the boardwalk? You know, the sand's too hot that he's not going to walk on it at all, right? Yeah, he complains too much. Yeah, you remind us of that, Savvy. All right, so we got a complainer on our hands. But this is a real problem. Actually, what happens is we change this problem in calculus, and trust me, this is a real problem. What you have is you have a lifeguard standing on the beach, and you've got a drowning swimmer. Well, not really drowning swimmer. There can't be a swimmer if they're drowning. A drowning victim that's in the water over here. And the question is, how far should they run along the sand before running into the water and swimming to the victim to minimize the amount of time it takes to get from here to there. Because they shouldn't just go into the water right away, right? Because you can run faster than you can swim, right? That's the whole idea. So he's faster on the boardwalk than he is on sand. He can walk at 4 feet per second on the boardwalk, but only 2 feet per second on the sand. So, so his path is going to look something like this. He's going to walk along the boardwalk, and at some point he's going to veer off and head straight towards the umbrella. And we wonder how long that is. Now, I'm going to warn you guys. This problem is going to take a very, very long time. This is nearly identical to the very last problem that you have on your homework test. And last year, they didn't have the patience to get through it. So I said, forget it. I said, I'm doing a video uploading it to YouTube. If you get it, great. If you don't, I guess you don't get the problem right. But first hour did pretty well with it. We didn't get all the way through because we had some delays for various reasons. And this hour, we will get through no problems. And we'll see how it works. So you need to have patience and say, this is the last problem, and this is the most difficult problem that we will see. Casey Gilbertson, are you ready? That's excitement. Vandy? Oh, my gosh. She's counting the time till he leaves for soccer. Okay. So here's what we got to figure out. We want to know the different times. He's got to reach there in exactly 4 minutes and 45 seconds. Okay? 4 minutes, 45 seconds. Now, that's his total time. So, we've got this. The boardwalk time plus the sand time is going to equal the total time, right? That's the most important part, that you could come with that type of equation. That's not an easy equation. That's a difficult equation. Try to think through that, be able to, work it out. Well, here it is. Boardwalk time plus sand time is 4 minutes, 45 seconds. Now, we know this. Time. Time is equal to, from the above equations that we had, time is equal to what? Time is what? Distance divided by rate. Very good. Now, as we look at their rates, are their rates expressed in seconds or minutes? Seconds. So we should really convert this whole thing to seconds. 4 minutes is how many seconds? 240 plus 45, 285 seconds. Let's get moving. So we have this equation. The boardwalk distance over the boardwalk rate plus the sand distance over the sand rate is equal to 285. What is the rate on the boardwalk? 4. What's the rate on the sand? 2. So now all we need is the boardwalk distance and the sand distance, then we can figure it out. Let's go up there and do some work. This is going to be the tough part. This is the boardwalk distance right here. We'll call it X. This right here is the sand distance. We have no idea what it is. We know that it has to be expressed in terms of X, right? Well, if you see here, I have a couple triangles. Do you guys see that I have 2 right triangles here? We're going to use that to our advantage. I want you to focus on the big triangle right here, okay? This one right here, this big right triangle. I want to know this distance so I can also figure out this distance, okay? I have X here. Let's figure out this value. In order to figure that out, I'm going to have to figure out this entire distance right here. How can I figure out this entire distance right here, knowing what I know here? A squared plus B squared is C squared. Very good. So we have A squared plus 210 squared is equal to 750 squared. Let's figure that out. I'll write it down. I've got A squared plus 210 squared equals 750 quantity squared. take out your calculator. Let's figure that out. You're going to have 750 squared minus 210 squared and square root both sides. Somebody get an answer, you tell me what you got. Very good. 720 is the entire distance. All right? From here all the way over to here is 720. So, if this is x, can you figure out an expression for what's left over? So let's say x was 100. What would this distance be? 620. So what did you do? You took 720 minus x. Very good. So this distance right here is 720 minus x. Now, please draw your attention to this green triangle right here. I want to know this distance right here. We'll call it y. That hypotenuse. I can figure that out using Pythagorean theorem too, right? So let's do that. I have 720 minus x quantity squared plus 210 squared is equal to y squared. I can square out that binomial as opposed to using the very large numbers. I'm just going to write 720 quantity squared. It'll be a minus, let's see, we'll double 720, get 1,440 times x plus x squared plus 210 squared is equal to y squared. Any like terms I can combine there? I got 720 squared and 210 squared, right? Let's add those together. What do you get? What's 720 squared plus 210 squared? 750 squared? That would be right if that's what you said. So if we take 720 squared and add to 210 squared, the result ends up being 750 squared. Okay, so you can try it on your calculator. So really what we have here is 750 squared minus 1,440 x plus x squared is equal to y squared. So if I want to solve for y, what do I do to both sides? Square root both sides. Very good. So what we end up with is this distance right here. This y value is equal to the square root of x squared minus 1,440x plus 750 squared. That's that distance. All right. I know that you don't remember all the stuff that we just covered, but you're going to know enough to now be able to complete the problem. Look at your drawing. What did we say is the boardwalk distance? What is the length that they walk on the boardwalk? How far did we say that was? It takes 4 feet per second, but x is just the representation of how long they walk on the boardwalk. So we have x over 4 plus, so we're using our main equation that we set up to solve this problem. The sand distance, well, that's the harder one. That was the square root of x squared minus 1440x plus 750 squared. And that's over 2. That's equal to 285, right? Now, I want you guys to know this. All we've done so far is we've set up the problem, and that's difficult to do. Okay, difficult, I shouldn't say all we've done. We've set up the problem to come up with an equation that's representative of that distance x, which is how far he walked across the boardwalk. Now, at the end of the day, I'm going to tell you guys that right now what we're doing, though, is algebra. These are skills that we practiced last unit, and these are skills that you learned last year. So now we are just solving an equation. So let's run the algebra through, and again, you guys will be able to follow the steps. Let me just remind you that the reason why we do this is because next year you guys will not be doing 2-step, 3-step problems. We'll get to problems that will take a full page, half a page, and you're going to have to be able to work through that. So I don't expect you to remember all this, but I expect you to be able to watch the video again or be able to look at your notes and walk the problem through again so you have success with it. I want to get rid of my fractions. What should I multiply through by? What can I multiply through by to get rid of my fractions? 4 or 8. You could multiply by 8, but we'll just choose the smallest one. We'll multiply through by 4. And I get a new equation. I get x plus 2 times the square root of x squared minus 1440. X plus 750 squared equals 285 times 4. 1,440? 1,140. Ooh, I got a square root. Anytime you have a square root, what are you going to have to do to both sides? Square both sides. So I should get everything over to one side first. So I'll subtract this x over. Write my new equation. 2 square roots of x squared minus 1,440 x plus 750 squared equals 1,140 minus x. What to do to both sides? Square it. What do I do with that 2 out front? What do I do with the 2 out front? Square it to get 4. What happens when you square the square root? Everything else goes away. X squared minus 1,440 x plus 750 squared equals, now I got to square that binomial. So we'll have 1,140 squared minus double that, 2,280 x plus x squared. We're almost there. What do you want to do now? So the D, distribute. 4x squared minus 1,440 x plus 750. Whoop, I'm sorry, I'm not distributing the 4 all the way through. Sorry. 1,440 times 4. What do you got? 5,760. Four times 750 squared. Oh boy. 2,250,000. That's all right. We just got some big numbers. Equals. I'll write the rest below it. 11,000 or 1,140 squared is 1.2996. 1,2996. 1,299,600 minus my 2,280x plus x squared. So again, all I'm doing is algebra right now. I'm just squaring this stuff. I'm multiplying. So I've got a quadratic. How do I solve a quadratic? You get everything on one side, so set it equal to 0. So I'm going to subtract off my x squared. What's that going to give me? 3x squared. I'll add a 2,280x to both sides. That gives me negative 3,480. I'll subtract the 1.2 million from both sides. I'll give me 950,400. You want to try? Yep, let's divide everything through by 3. 3,480 divided by 3. 1,160. 950,400 divided by 3. 316,800. It's a binomial, right? It does factor. You could also use a quadratic formula, right? I'll just factor it for you. Do you guys have the quadratic formula on your calculator? Well, let's get it programmed in. We won't do it today, but so when I get to a problem like this, I don't have to run through the algebra. I know how to do that. So to avoid, working with big numbers, I just plug in the quadratic formula on my calculator, and I get minus 440 minus 720. So what are your two solutions? 440, 720. That's what x equals. Does that answer my initial question? What was the initial question? And what is this? That's how far he walks on the boardwalk before he veers off, right? So he's got two options. He can either walk 440 feet and then veer off, or he can walk the complete 720 feet and then go straight down. Either way, he'll get there in exactly 4 minutes and 45 seconds. So we've found the answer. Now, is that the longest problem you've ever gone through? Good. You need to start seeing those because they're real. All right? And you need to start moving towards those. I'll tell you guys right now that we do more word problems in chapter 2.7, but because of the practice you guys get right now, 2.7 last year went awesome. 1.6 went not horrible, but not very good. So made some adjustments this year in terms of problems we ask. I want you to work hard whatever time you have now. But tomorrow, you might just want to take a break the rest of the day, okay? You've seen a lot of stuff, all right? All right? So, what's that? Well, I'm going to give you some work time on Monday, and there's just like 2 more problems from your book I want you guys to look at. So let's just look at those tomorrow, okay? I just want you guys to see the whole scope of the problem. But I want you guys to know that that's the type of problem you got to be able to see. And it's not that you have to remember how to do it just to show up to it. But if you can follow your notes, and if you can watch a video and follow it, then when you get to the homework test, hopefully you can reduplicate it. I would say about a third of the students last year in pre-calc were able to get through that problem then on the homework test. I expect more than half of you guys to be able to do it. Because you're way smarter than they are, right? All right, that's all for today.